Okay, so continuing these notes, now we're going to see problems where we have something raised to the power of 0 becoming 1. Now some of these will be very straightforward. So let's write down 0 exponent. The instructions have not changed. I'll underline this as a heading, and I'll put simplify, and then EX period. So first of all, let's say we got something that looks pretty ugly, like negative 3x to the power of 5. That's poorly written. Let me fix that. Negative 3x to the power of 5 times y over 8xy to the power of 7. Now here's what the mistake is. The mistake is not noticing that there is a 0 exponent that this whole thing is being raised to. And I point that out because normally if we get so practiced and we're used to doing something the same way again and again, we might want to cross out this x and put 4. And then we might want to cross out this y and put 6 down here. But you'll end up creating so much more work for you because anything raised to the power of 0 is just 1. This problem in one quick step is done. Now, even though that may have been easy and straightforward, if those show up in your textbook, I still want you to rewrite them. Okay, now let's take a look at a slightly different version. Here's t cubed s to the power of 0. Make sure that you know that's an s and not a 5, all over the power of t. So I scan left to right. I see a t. Now I see 3 up top and 1 down below, so there are 2 more up top than there is the 1 down below. And maybe I'll jump into writing t squared right now, which will be in the numerator because there's more up top than down underneath. Now this s to the power of 0, well, that just is 1, so I'm not going to bother rewriting anything. And if you're comfortable, just show it being slashed out. But if you're not, put times 1. Now I don't have to put times 1 because there's something else over here and I know that there's value. So this problem is finished. That's t squared. Let's look at one more. X to the power of 0, y to the 4th, over y squared. Make this on your own. I'll do the answer quickly. Well, this just becomes 1. Y to the 4th is 2 more up top than underneath, and so I can write y squared. If you don't show that 1 there, it doesn't matter. But here's the deal. If I would have had an x, that would have been written out front, because x is earlier in the alphabet. Also, with the other problem, QRST, I probably would have written t before that as well. We'll move into problems involving negative exponents. But the other thing, too, is, like something you want to keep in mind with negative exponents is that, like I said, it's repeated division, so you can flip those. And this goes both ways. Like, so if you wanted to swing from the right side to the left and move something down because it helped you out, you totally can. That'll be clear as we do more problems. The other thing, too, I want to point out is that when this said a to the m over a to the n, they didn't really give us any examples where we ended up with negative numbers. But believe it or not, there will be times where you have x squared over x to the 5th, and you could do 2 minus 5 to get x to the power of negative 3. Which would really be the same as flipping that upside down because of this rule and saying, well, 1 over x cubed. But I kind of prefer to see there's 2 up top, 5 here, there's 3 more underneath. So doing it either way ends up giving me the same result. Rewatch that if you want to. I said it quickly, and I think that makes sense. But if you want to talk about it as a class or individuals, we can go through that. So let's look at what happens when we have negative exponents as the new type of problem. Negative exponents. Underline that, same as before. The instructions are most always going to be simplify. And then there's also that non-zero qualifier, meaning like you have to assume the denominator is not equal to 0. Okay, let's take a look at a slightly challenging problem, but not crazy. xy squared over y to the negative 3rd. Now, you have an option. You could just do 2 minus a negative 3, which would give you a positive 5, and that's going to work great. but I want to use the negative exponents rule so we can communicate this concept. Now the numerator is the numerator, but that y to the power of negative 3 is in the denominator. So really this is what that y to the negative 3 looks like. And so I can ricochet, I can bounce this negative exponent up to the numerator, and I can think of that as being over 1 if I want. So I'm putting this off to the side in red so that you can see that as I try to deal with x, there's nothing else I can combine x with. And also, is it positive to begin with? Okay, we're good there. Then I'm going to scan left to right, dealing with my numerator. Oh, I see y squared. Well, that's a positive, so I will write y squared in a place that will eventually become my numerator. And I look to the left to right, and I see that there's nothing else from my numerator. So now I think about my denominator. Well, y to the power of negative 3 I just talked about, so now I'm going to write y to the power of 3 in my numerator. Well, that means that I no longer have anything in my denominator, so I think I'm done with dealing with negative exponents. So here's x times y to the power of 5, because in earlier videos we saw we can just put those together. Now here's the deal. In order for these types of problems that you have to be totally simplified, you cannot have negative exponents. No negative exponents tells you that that end result is completely simplified. Okay, let's look at a more challenging problem now. B to the power of negative 3 in the numerator of a fraction times c squared over d to the power of negative 5. I'm going to scan through my numerator, left to right. Well, I see b to the power of negative 3, so why don't I set up a fraction bar and bounce that b to the power of 3 down here. I've dealt with b. After that I see the value of c squared, and that has a positive exponent, so I'm just going to rewrite c squared there. Rescan my numerator, there's nothing else to talk about, so I'll move to my denominator, and I see d to the power of negative 5, which will get written as a positive, and I'm moving it up to my denominator. Now I think I've written this neat enough, but it's good to keep things centered, so maybe I'll shuffle this over a little bit. And it just so happened that in alphabetical order I worked this out. There's C, D, there's B. So maybe as a final step you end up rewriting everything to keep this in order. Last question for this one. Are there any negative exponents? Oh, we're done. Can we cancel anything out? You can't. So this one's finished. I often avoid canceling anything until I get to where I have no negative exponents. Quickly, these problems can get way more involved. Write this down. I think for our sake today, I'll color code this with negative 3 and 21 so that we see that those values match up. Now that's a negative number. That has nothing to do with exponents. So that's just a negative number. And then I have something with a to the power of negative 4 and a squared down underneath. Then I have b to the 7th, and I'm using red, but you're fine knowing that I mean, well, keep that in there. Don't cancel anything out. And then I have c to the power of negative 5. Now you can do this in all sorts of different order. So let's first scan left to right, and I always like to deal with numbers only if I can. I see negative 3 over 21, and I know that that negative usually stays up top because that's the conventional way of showing a fraction. I give myself a clear enough fraction bar so that it separates all the space I need, most likely up top, and all the space I need down below. I'm staging my problem so later I don't run out of room and have to sketch it strangely. I'm not going to bother putting a 1 because I prefer not to, but I do know that 21 is 7 times bigger than 3. So here's my 7 down below and my negative up top. I'm scanning left to right with my eyes and I see a. Well, That's a to the negative 4. So I'm not going to start combining things because I think if I start combining a's, that will mess me up. But what I will do is I will write a to the power of 4 in the denominator because I'm taking the negative exponent, making it positive underneath, and just stopping there. You kind of have a choice. If you wanted to, you could write a squared now, but I kind of want to not jump around, so I'm still scanning the numerator, and I've made it this far, and I see B7. Well, B7's fine as it is, but guess what? It totally matches. Cancel that out. So now I rescan the numerator, and I dealt with the negative 3, the a to the negative 4, and the b to the 7th. So now I'm going to move on down to the denominator. Checking out the denominator, well, we already dealt with that 7, and now I have a squared, so I'm going to write a squared. I see b to the 7th. Well, we've already canceled that out, so I keep going until I see c to the power of negative 5. And c to the power of negative 5 gets moved up top and becomes positive, and I am tempted to box this, but I won't, because in my numerator I have negative c to the power of 5. There's no combining any c's anywhere. I do have 7 as a coefficient for this denominator part, and a to the 4th, a to the 2nd can be combined to become a to the 6th. And then I can box that. Hopefully that feels comfortable. In columns we're going to work, so now you'll be moved to the right, but I'm going to clear my page and just show this in the same space. I've colored this so it stands out. I have negative 3 times q to the negative 2nd r s to the 4th in the numerator. And then in the denominator I have negative 12q r to the negative 3 s negative 5, s to the power of negative 5. So as I'm going through this, you can try this OYO if you would like, but I will still definitely explain this in detail. So here we have negative 3 over negative becomes positive. I can make that first change if I want. I can change this 3 and 12 to 4 because 12 is 4 times bigger than 3. But all of these are, opposites. Like there's a positive, there's a negative exponent. There's a negative, there's a positive. There's a positive, there's a negative. So I'm not going to cancel anything out right now. But what I will do is I will scan through the numerator, and I'll set up my fraction bar first this time, and I see q to the power of negative 2. So I will write q to the power of negative 2, but as a positive underneath. So that deals with this part. Well, r is already positive, so I'll write that up top. And s to the 4th is already positive, so I'll just write that up top. I scan through my numerator, and my q is written, my r is written, so is my s to the 4th. Well, down beneath, I have to be careful and not go too crazy quick, because here's that 4 I wrote, and that can go out front. I keep on moving left to right with my eyes, and I see a q. I move left to right with my eyes, and I see an r to the negative 3, which was in the denominator, so I will rewrite it as a positive up top. I've dealt with the 4, the q, the r, so lastly I have s to the negative 5th, which becomes s to the positive 5th up top. Alright, A, B, C, D, F, G, blah, 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 blah. R comes before S in the alphabet, so I'm combining things now, and I see R to the 1st and cubed, becoming R to the 4th. S would follow that in the alphabet, so I'd write S to the power of 9. Show a fraction bar, scan through and write 4, and then I have q squared times q, which would become q cubed. And if that r is unclear, let me rewrite it. I look through this, and I'm trying to cancel things out. And keep in mind, this is not 5 to the power of 9, that's an s. So always try to keep your s's as clear as possible. A little tip. If you really dislike QRS, you can replace Q with X, R with Y, and S with Z or something, but just make sure that you keep it consistent. And I can't imagine that most teachers would really care if you did that. Here are 2 more problems that will become on your own problems, and they also will be problems that I will have you check on Wolfram Alpha for practice And the reason is this. These are challenging. These are different. You kind of have to experiment and try your own ways at times to feel more comfortable with them. I will read these just to make sure you see what they say. R to the negative fifth times S to the fourth over T to the negative 3. The other one says 24 times X to the negative second, Y to the fourth, over negative 6, X to the negative 3, Y to the negative 2, Z to the negative 1. But again, finish these on your own. After you do the first one, check it in Wolfram Alpha. The way you would do an exponent, as you know, is like that, 2 with a caret and then 4. And it's no different if you put a negative on it. Maybe you need to put something in parentheses, but make sure those fractions get opened up and broken apart. And it'll display the input that you use. So you should be able to check to see if you typed it in correctly. The assignment that will go with this is here. And these problems might be lengthy, especially if you're checking them in Wolfram Alpha a lot of the time. And that's okay, and that's why I put the little reminder note for about 30 minutes a night. And yes, you could use these as like vocab cards for a bit or cheat sheets, which I think is helpful. But at the same time, if you really understand how exponents work, these should feel a lot more comfortable.